So Unit 4, Lesson 2. Some more exponent rules we're going to take a look at. A couple last exponent rules. The zero exponent rule. We've looked at multiplication rule, division rule, and power rule. Zero exponent rule. If you were to type these all into your calculator, 2 to the 0, negative 4 to the 0, 3 over 4 to the 0, 23 to the 0, negative 17 to the 0, you would end up with 1 for your answer. Don't believe me? Try it. Basically, the zero exponent rule is the easiest rule. Anything to the exponent of 0 will always equal 1. Anytime you have an exponent of 0, it will always equal 1. Be careful. You've got to be careful with brackets, though. So this question, everything in the brackets has an exponent of 0. So that means everything equals 1. This question, though, there's no brackets. So the only thing that goes with the 0 is the 8. The negative stays in front. So 8 to the exponent 0 is 1. So we have an answer of negative 1. C. Be careful with the brackets again. This time, the brackets are there, but the 0 is inside the bracket versus being outside the bracket in A. If it's inside the bracket, the only thing that goes with the 0 is the x. So we would have negative 3, we'd have 4, and x to the 0 is 1. So we have negative 3 times 4 times 1, which is negative 12. So be careful with those brackets, but basically anything to the exponent 0 is 1. Last one we're going to look at is negative exponents. And I've got a couple tables here already filled in. Take a minute, pause the video, and look at the tables. Okay, you're back. If you really seriously looked at these tables, you would notice 2 to the exponent 3 is 8, 2 to the exponent 2 is 4, 2 to the 1 is 0, or sorry, 2 to the 1 is 2, 2 to the 0 is 1, and if you type in your calculator 2 to the negative 1, you get 0.5. And 0.5, I would hope we all know, is a half. And if we typed in 2 to the negative 2, we get 0.25. And I would hope we all know that's a quarter. And 2 to the negative 3 is 0.125, and you may or may not know that's an eighth. But if you look at our table, look carefully. We had 2, and we have a half. We have 4, and we have 1 over 4. We have 8, and it would follow we would have 1 over 8. There's a pattern going on there. We look at our other table, same idea. We had 10, and we have 1 over 10. We have 100, and we have 1 over 100. We have 1,000, and we have 1 over 1,000. There's a pattern going on in the table. So if you look at the table carefully, the pattern is 2 to the positive 1 is 2, but 2 to the negative 1 is 1 over 2. And 2 to the positive 2 is 4, and 2 to the negative 2 is 1 over 4. So a negative exponent basically equals the same as the positive exponent, except it's flipped around. And we call that the reciprocal. It's flipped around. So the way we evaluate a negative exponent is to look at the base and take the reciprocal. So if I have a to the negative n, a to the negative n is really just a over 1. So when I flip it around, the 1 goes to the top and the a to the n goes to the bottom. Be sure when you flip it around to remove the negative, because by flipping it, it takes off the negative. Or vice versa. If I start out with 1 over a to the negative n, if I flip it around, it would be a to the n on top and 1 on the bottom. And if I have 1 on the bottom, that really doesn't count. It's just a to the n. Because I flipped it, the exponent is positive. If I start with a fraction, top number, bottom number, To evaluate, I flip them around. The bottom number goes to the top, and the top number goes to the bottom, and the exponent is positive. Make sure you get rid of the sign. So if we look at a couple of examples, if I have 5 to the negative 3, that's really over 1. I flip it around and I make the exponent positive. So I have 1 over 5 to the exponent 3, which is 1 over 125. If I have a negative base and a negative exponent, the two negatives do not cancel each other out. The negative exponent means to flip the base, take the reciprocal. So if I have negative 4 to the negative 2, it's negative 4 over 1, so it becomes 1 over negative 4, and the exponent becomes positive, which would give me 1 over 16. If I start with a fraction, 1 over 3 to the negative 4, and I flip it around, I'll have 3 to the positive 4 over 1, and over 1 is just 3 to the 4, and 3 to the exponent 4 would be oh, I did that wrong, not 27. 3 to the exponent 4 is 81. We keep going with a little bit more difficult questions each time. If I start with a fraction, the number that's on top will flip to the bottom. So I'll have 2 to the x. And the number that's on the bottom will flip to the top and make the exponent positive. And then I would evaluate. So I would square everything in the top and square everything in the bottom. So I'd have 25 y squared over 4 x squared. A couple more. So brackets are important. We talked about that earlier. Same with negative exponents. Number 4 had brackets, so everything flipped. When there are no brackets, the negative exponent only goes with what's right in front of it, which is the x. That means the only thing that flips is the x. So the 2 would stay the same, the 3 would stay the same, but the x would flip from the top to the bottom and make the exponent positive. And then we're done. Because x cubed, I don't have a number, so I can't evaluate. And if I look at the last one, whatever has a negative exponent flips around. So there's no brackets, so the negative exponent goes with just the x, not the numbers. So if I have the numbers stay the same, but the x's flip around. So I would have x to the 2 over x to the 4. Flip them around and make them positive. And then we can simplify. 5 goes into 10 twice, so I actually have 1 over 2. And if I have x squared on the top and x to the 4th on the bottom, I have more x's on the bottom. So I would have 2 more x's on the bottom, so I'd have 1 over 2x squared. So the negative exponents get a little trickier with all this flipping around. Last thing, once we know all 5 exponent rules, multiplication, division, power, 0, negative. Once we know all the exponent rules, then we can use all of them to simplify. Be sure to use them in the right order. You want to use the power rule first, then multiplication and division, and then your 0 or negative rule. So if I look at a more complicated example where there's a whole bunch of rules, I look at this one and I see that I have got multiplication. I've got a power rule because I have a power to a power, and I have a negative exponent. I want to do the power rule first, the multiplication second, and the negative exponent third. So if I do the power rule first, first bracket does not change because it's on a power to a power. The second bracket, though, all the exponents inside the bracket get multiplied by -1. So I have -2 to the -1. I have x to the negative 2, and I have y to the negative 3 when I multiply all my exponents. So I've done my power rule. Second rule should be my multiplication rule. So I'm going to multiply my two brackets together. So I have got 3 times negative 2 to the negative 1. And when I multiply the same bases, I keep the base and I add the exponents. So I have x and 2 plus negative 2 would be 0. So they're gone. Nothing left. And then I've got y to the negative 1 and y to the negative 3. When I add my exponents, negative 1 plus negative 3 will give me y to the negative 4. So I did my power rule, then I did my multiplication rule. Last step is the negative exponent rule. Whatever has a negative exponent gets flipped. So if I put it over 1, the y has a negative exponent and the 2 has a negative exponent. The 3 does not, so it will stay in the top. So I have 3 over negative 2, y to the 4th. Remember to make the exponents positive when you flip them. And at that point, we are done. We've used all the exponent rules we can use. If we look at our second question, I see in my second question, I have a power to a power, I have multiplication, and I have division. I have to do the power rule first, then my multiplication, and then my division. So if I do my power rule first, everything in the bracket gets squared. So I have 25a squared times 5a to the 4th over 5a to the negative 4. Second thing I do is my multiplication. So I have 25 times 5, which is 125. I'm multiplying the same base, so I keep the base and I add the exponents. 2 plus 4 is 6 over 5a to the negative 4. And last thing I do is my dividing. 125 divided by 5 should be 25. When I'm dividing with the same base, I keep the base and I subtract my exponents. Be careful subtracting with negatives. What we are doing is 6 take away negative 4, which is actually 6 plus 4. So my exponent will be 10. The reason we leave our negative exponents to the end is sometimes when we do all the other rules, the negative exponents work their way out and we don't have to do any flipping. So make sure you leave your negative exponent to the very end. All right, that is all 5 of our exponent rules. So you will need to practice those exponent rules and you will need to memorize them and know all 5 of them to be able to do the next journal.